Alright, so yesterday we talked about your steps, and you can check yours along with mine as you go. Alright, so you guys were factoring the numerator and the denominator. When you factor the denominator, remember you got to take out that GCF. So you have x squared plus 3x, so you're going to take out the x, and then you're going to be left with x plus 3, and that's all you can factor there. Here you're looking for two numbers that multiply to a negative 6 but add to a negative 1. So you have x minus 3 and x plus 2. That's how you get the negative 6 and the negative 1. Okay, for your x-intercepts, you find zeros of the numerator. So if you're finding the zeros of the numerator, you can just set x minus 3 and x plus 2 equal to 0 and solve. So x is 3 and x is negative 2. These are your x-intercepts, 3, 0, and negative 2, 0. Okay, for your y-intercept, okay, you plug in x is 0. So whatever your function is, that's the same thing as y equals. If you plug in 0 in the numerator, you're just going to be left with what? Negative 6. Now, in the denominator, you have 0 on the bottom. If you do negative 6 divided by 0, what happens? Yeah, it's undefined. You get an error. So if it's undefined, okay, then there are no y-intercepts. So I plugged in 0 for x, so the 0 squared plus 3 times 0 will give you 0. Yep, for the y-intercept, you always plug in x is 0. And really, for the x-intercept, we are setting this equal to 0. Remember I showed you yesterday how you multiply, and then you would just get the numerator equal, so you don't have to worry about that part. Okay, and then you're going to do your vertical asymptote, which is always the zeros of the denominator. So for the denominator, you're going to have x equals 0 and x plus 3 equals 0. So x equals 0 is one of the asymptotes. This one is going to give you x equals negative 3. Okay, so we are going to put those on a graph. Oh, sorry, actually, this was, I think I did the intercepts together as step 2. This was step 3, and step 4 is the horizontal. Okay, so for the horizontal, you're comparing the degrees of the numerator and the denominator. So the degrees of both of these are 2. So if the degrees are equal, then you use the leading coefficient of the top over the leading coefficient of the bottom. What's the leading coefficient for each of those? 1. So it's 1 over 1, which is just going to be y equals 1. So if the degrees are equal, you do the leading coefficient over the leading coefficient, which is just 1 over 1 in this case. Okay, 1 over 1 is 1. Okay, and so now we are going to graph. And when you're graphing, I like to put the asymptotes on there first. We're going to use our graphing calculator to plug that in. And then once you go to that 10 by 10 window, if you can see all of the branches on your 10 by 10 window, you know that you are not going to have to change your scale. Okay, so in parentheses, you have to do the x squared minus x minus 6 divided by, and then this has to go in parentheses as well. Okay, and I'm just going to make sure I'm in my standard window. So this one has 3 branches in it, just like the last one that we did. And so I can, oh, this is a 5 by 5. Let's see if that's enough. So if I do negative 5 to 5 and negative 5 to 5, let's see if that's enough. And I can see 1, 2, 3 of those. Okay, you could also scale by 2s if you wanted to see more of it. That is fine as well. All right, so we're going to put in our asymptotes here. So we have x equals -3. So 1, 2, -3. We like to put these in first. These are really giving you the bounds of where the branches are going to be. Those are called branches. Okay, and then you have x equals 0. And then, like I said, sometimes I like to use my highlighter to make this one a little easier to see. Okay, and then the last one is y equals 1. And those are dashed lines. So you have your y equal to 1. And then you already have a few points to plug in. You have 3, 0. So 1, 2, 3, 0. You have -2, 0. Okay, so you can use those as part of your grid. Okay, and then from there, I said you could just use your table. All right, so if you're at x equals 0, you should see an error on your table. Okay, at 1, you're at -1.5. At 2, you're at -0.4. We have the 3, 0. Okay, and you can see these keep going up. So they're getting closer and closer to that value. Another good thing sometimes to check is in between where your asymptote is and this point. So if you wanted like your table to start at 0 and go by a half, you could do that as well, because then you can see what's happening here at 0.5. So at 0.5, I'm at -3.5 approximately. And then that just helps you create this part of your branch. And then this is curving upward. Okay, and then this is just being connected with your curve. All right, and then between 0 and -1, you're at 4.2. So at -1/2, 1, 2, 3, 4.2. Okay, at -1, you're at 2. Okay, at -2.5, you are at -2.2. Okay, so if you look at your graph here, you can see that this is just curving through here. This looks very similar to a cubic function. Okay, so you're sketching that part of it. Okay, and then at -4, you're at 3.5. 1, 2, 3.5. At -5, you're at 2.4. Okay, and this is going to create this branch here. Okay, now for this one, when you are doing your domain and range, this one is a little bit special with your range. Okay, so the domain is always going to exclude whatever your horizontal asymptotes are. So it can be values of x such that x cannot be 0 or -3. You can write those in any order you like. Okay, so it cannot be those horizontal asymptotes. And then remember yesterday with this one, we have the 3 branches and they were above this line or they were below this maximum value. But look at this graph. Look at the y values. What's the lowest y value you have? -infinity. What's the highest y value you have? Infinity. And are there any breaks in there where the graph doesn't cover it? No, because look at this. See how it's going all the way up, all the way down? So if you have this cubic type function in your graph, what do you guys think your range is going to be? All real numbers. So y is an element in the real number set. Okay, and we're going to talk about those different types of domains and ranges today, so you kind of have a guide to help you depending on what your graph looks like, because we've already seen 3 different types of rational functions here. We have this one, and this one, and they were all different. Okay, and it's all dependent on their degrees. And then last year, you guys actually did some of this where you had slant, or they're called oblique asymptotes. Okay, and this is going to happen when the degree of the numerator is 1 more than the degree of the denominator. So when the degree of the numerator is 1 more than the degree of the denominator. Okay, so make sure you know, like, this case. So, like, know how to explain it. Know how to explain when a slant asymptote is created. Okay, so when that happens, there is a slant asymptote. So to find it, we are going to use, you guys remember? I honestly would be very impressed with you. We're going to use long division. Does that ring a bell at all? I know it's been a long time. Okay, so we're going to use a long division to divide the numerator by the denominator. And then your asymptote is the quotient. So the asymptote is going to be y equals, and it's the quotient only. Okay, and it's when you divide the numerator by the denominator. Okay, so the quotient, and you divide the numerator by the denominator. Now I want you to think about this. We said that in order for this to occur, the numerator has to be 1 more than the degree of the denominator. So if you divide them, if there's only a 1 degree difference, that means your asymptote is always going to be what type of a function? Linear. Good. So it's always linear because the difference is 1 degree. That means if it's linear, you are going to be writing this in the form y equals mx plus b. Okay, so this should always be in the form y equals mx plus b. Okay, now remember, if the numerator is greater in degree than the denominator, remember how we wrote no horizontal asymptote? So that's the rule. If the numerator is greater than the denominator, there's no horizontal asymptote. That's because there's a slant asymptote, as long as the degree is 1 more. Okay, so you will never have both a horizontal and a slant. Okay, you can only have one or the other there. All right, and then just like the horizontal asymptotes, the graph of the rational function, it can cross a slant asymptote, but that doesn't always happen. So we're going to look at some graphs on the next page, and then we're going to write some domains and ranges and set builder notation. So we're going to do that together. Okay, and this is just going to give you some guidance on what to do, because now we have even another type of a rational function. Okay, so if there are vertical and horizontal asymptotes, okay, like we have in here, let's put these in. So anytime it's a vertical, those are going to be excluded. Oh, also, if you have like an older model of your calculator, they put the horizontal asymptotes in there. So if you notice, like when you graph this, it looks kind of like a heart rate. It's the it's the asymptotes that they're showing you. So this would be x is equal to 3, x is equal to -2. Those are the horizontal. And for your domain, we know x can't equal those vertical asymptotes. So it would be x such that x cannot be -2 or 3. So we can just put a comma. Okay, now when you are doing the range, this is similar to the one that we did yesterday. Okay, so you're going to have to find the max value. The maximum is not necessarily the same as the y-intercept. Okay, in this case, it definitely isn't. In some cases, it might be. I just don't want you to think that happens all the time. So sometimes it does happen, but not all the time. Okay, and so this is one for whatever your range is. It has to be less than or equal to the max value, and it's the y-coordinate because you're dealing with y's. Or you also have a horizontal asymptote here, and it gets very, very close to that at y equals 0. Okay, so or it has to be greater than the horizontal asymptote. Okay, in this case, we do not know what the maximum value is. In this case, you would put y is greater than 0, but it doesn't have to be 0. So we're just going to write out what that is in standard form. Okay, now sometimes this will cross the horizontal asymptote. If that happens, we're going to write out what your range should be. Okay, so if it crosses the horizontal asymptote, then the first part is the same. So it's y such that y is less than or equal to the max. It's equal to because the max is part of the parabola. Or you would have to do y is greater than or equal to the lowest point or the minimum value. So you would have to find your minimum on your graphing calculator. Okay, and then once you find your minimum, you will put y is greater than or equal to that value. It'll only be not equal to if you have the horizontal asymptote. All right, now this one has vertical and oblique. So oblique are slanted. So this is a linear function. It goes through the origin here, which means the y-intercept is 0. And then look, it's 1 unit up, 1 unit over. Okay, so this asymptote here is y equals x. And you guys would go ahead and find these. We're going to practice finding them. And then x equals 0. So your domain is always going to be excluding your vertical asymptote here. So it's the x equals 0 that it cannot equal. Okay, and then here for your range, you have 2 branches. So it's either all of the points that are above this value is a minimum, or it's all the points that are below this maximum. So when you're writing out your domain, it's y is less than or equal to the max, or y is greater than or equal to the min. Okay, so you're going to have to use those functions again in your calculator to do that. Okay, so you might notice that these are the same. They are. Okay, so you might have to find a minimum there. Okay, and the last one is if you have both horizontal and vertical. So again, we're going to find those vertical. You guys write what your x is going to exclude, and then I want you to write what the range is based on what we've done today. Okay, so what can x not equal for the last one? What do we get for the, yeah, so you guys are finding those two, right? Do we have any trouble with that? Okay. And you can see it's labeled here, right? Okay, and then what was our range? All real numbers. So you do have this y equals 1, but look at this line. It crosses all of that. So your range is going to be all real numbers. Okay, so this is a great thing to use after you graph. Okay, so you can see those different cases that we talked about. Okay, and then we're going to find the slant asymptotes for the following functions. So when you have to find the slant asymptotes, you are going to be doing long division. Okay, so it says to identify the slant asymptotes. We're just going to do a quick check anyway and make sure that the degree is 1 more than the denominator. Okay, so we have 3 and 2. Yep, here we have 3 and 2. Yep, so we know that there is going to be one that exists. And then we're going to do long division. So we have 3x cubed minus 4x squared. Remember, if you are missing one of your terms, I just recommend putting the 0x in as a placeholder. Just to make sure that you're lining those up. You could also put a placeholder in here too if you wanted. And then you can divide. So 3 divided by 1 is 3. X cubed divided by x squared is x. And then we're going to distribute. So we have 3x cubed minus, and then I'm going to put this here, minus 6x. Okay, and then we're going to change the sign. So negative 4x squared drops down, plus 6x plus 1. Then we're going to start the process over again. So negative 4x squared divided by x squared is negative 4. So these should match up before you change the signs. A negative times a negative is a positive. So I'm going to line up my like terms there. And then switch your sign, So this is going to be 6x. 1 minus 8 is negative 7. Okay, and then this is just your remainder. You remember you stop when your degree of your remainder is less than your degree there. So the slant asymptote is only your quotient. So your final answer should be y equals 3x minus 4. All right, so I want you to do part B. That's what creates the slant asymptote. If they're asking you to find the slant asymptote, though, that should happen. But if they're just asking you to graph it, then that's something that we should check. Okay, and again, you can put your 0x in there. You can also just make sure you line up your like terms. Okay, so 2x cubed divided by x squared is going to be 2x. Now, when you multiply, you get 2x cubed minus 2x. And then you switch the sign, so this is 4x. Now, this degree is less than that degree, so your slant asymptote is just y equals 2x. Okay, your y-intercept 0, your slope is 2. All right, so we're going to graph with these. So this just says to graph r of x. You're going to find the intercepts and the asymptotes. You're going to state the domain and range and set further notation. And then we can use our graphing calculator to help us. Okay, so we're going to graph. We're going to do the intercepts and the asymptotes. And then we still have to do that domain and range. And the set of the notation. All right, so just like we did before, we're always starting off by factoring. So the GCF in the numerator is x. So if you factor out an x, you're left with x plus 2. Nothing to factor in the denominator. Okay, now we're going to do the intercepts. So the intercepts, we do the numerator. So for the x-intercepts, you set the numerator equal to 0. So we either have x equals 0 or x plus 2 equals 0. Okay, so this is one of your x-intercepts. The other one is -2. Okay, and you can write them like this, or you can write them as your points, 0, 0, and -2, 0. That is what we're going to plot on our graph. So we already have 2 points here that we know we're going to put on the graph. Okay, for your y-intercept, you're going to plug in x is 0. So when you do that, your r of x, remember, is the same thing as y. It's your output. So if you plug in 0 in the numerator, you get 0. If you plug in 0 in the denominator, you get -1. And if -1 is in the numerator, you can give 0 away, so you can divide. 0 divided by -1 is 0. Okay, so your y-intercept is 0, 0, which makes sense because that was also your x-intercept. Anytime you have 0, 0, it's both your x and your y. Okay, and then the vertical asymptote is always going to be zeros of the denominator. So if you have x minus 1 equals 0, x equals 1 is going to be your line. And then we're going to compare for the horizontal. So for the horizontal, we're looking at the degree. So the degree of the numerator is greater than the degree of the denominator. Okay, which means there's no horizontal asymptote. But now we have to check for oblique. So if the degree is 1 more, okay, then there's a slant asymptote. So that's what we have in this case. Okay, so for ones like this, it just says find the intercepts and asymptotes, so we do want to check to see if there is a slant, and there is. The only time you have to check for a slant is if you get none here, okay? All right, and so go ahead and divide. So we're going to do x squared plus 2x. And then once you do that, you want to put it in your graphing device. All right, so how many times does x go into x squared? 1 time. So if you have x on the top, we distribute. So you have x squared minus 1x. Switch your sign, switch your sign. Okay, and then divide. 3x divided by x is 3. So we have 3x minus 3, switch your sign, this is your remainder. Okay, so then your slant asymptote is only the quotient, so it's y equals x plus 3. Okay, so that is your slant asymptote. Okay, so when you graph this, we are going to do it on our graphing calculator. When you graph this, it's just graphing a linear function. Okay, and again, make sure that you are putting in those parentheses. Anytime you have more than one term, you got to put those parentheses in. Okay, so see how this 5 by 5 wasn't enough, so I'm just going to change my window back to the 10 by 10. You can also go to Zoom Standard. All right, now we can see those two branches. All right, so if I'm graphing this, I'm going to start at 3, right? I'm going to start at your y-intercept, 1, 2, 3, and then we're going to find the slope. Okay, so you always start at the y-intercept, and then your slope is 1 over 1. That's your rise over run, so up 1 over 1. And then just like we've done with all of our other asymptotes, it's going to be a slanted line. And then you can go down 1, back 1. And then you want it to span your whole grid. Okay, and these are creating the bounds for where your branches are going to be. Okay, and then you have another one at x equals 1. So when you have these slant asymptotes here, you should have like a little branch up here and a little branch here. A lot of times there is an x. So we're going to use our table. We're also going to use the points we found earlier, so 0, 0, and negative 2, 0. Okay, so remember how I put my table set by the halves? I'm going to start at 0 and go by halves. That is just helpful so you can see what's happening in between like this 0 and the 1. So it's negative 2.5, so that's going to help you with that. And then negative 1 is going to be helpful. Negative 1 is at a half. Okay, and then this one here, that's going to be helpful as well. So at negative 2, you're at 0, but at negative 2.5, you're just underneath that. One, 2, 3, 4, 5, and I'm at 1, 2.5. So you're really just going to be following this line here. And so once you start to recognize that pattern, you can curve it down. Okay, remember it's never going to cross. It's never going to cross the vertical. So just be careful about that part. And then let's go over to 1.5. Okay, so at 1.5, I'm at 10.5. So I'm up here. At 2, I'm at 8. At 3, I'm at 7.5. Okay, and then again, once you have enough points to create that curve, you can do so. All right, now we have to do the domain and the range. So for your domain and your range, we know the domain. That's a nice pattern, so x cannot be 1. Okay, for your range, we look at what we talked about with the asymptotes above. We have to find the minimum value and we have to find the maximum value. Okay, so we're going to find this minimum value on our graph. So we're going to go to second calc. Okay, so you have to find the min and the max. Okay, so we can do the minimum first. So to find the minimum first, you're going to have to arrow over so it jumps over here. So you just keep pressing to the right because you want it to go to the right. Okay, and then we're going to do the left bound and then the right bound. And then it will find the lowest point between those. Okay, so the minimum, the y value of the minimum is 7.46. And then we're also going to find the y coordinate of the maximum. So again, when you're doing this, I'm arrowing over to the left because I want it to the left here. And so I'm going to set my left bound and my right bound. And then once I set those bounds, it will find the highest point in between those bounds. So my max was y is 0.54. Okay, so is it lower than the max or higher than the max? All the points are below it. So y is less than or equal to that max value, or y is greater than or equal to your minimum value. Okay, so it's less than or equal to your min, greater than or equal to your max. All right, and then I'm going to give you the rest of the time to work.